All right, before we move on, let's go ahead and take a little bit deeper look at what we're doing here. The thing neglected to mention in the last video is, well, what kind of efficiency are we talking about? So, along this curve, the points A, B, C, and D, what kind of efficiency are they? Okay, so remember I had two kinds of efficiency before. We had productive efficiency and we had allocative efficiency. And take a second to remind yourself what those mean. You might want to even pause. So which kind is this that we have going on along our curve? Okay, so let's see. So if you said that this is productive efficiency, you're right. So the points along the PPF that we have productive efficiency, and it's productive efficiency because that's as good as we can do given our resources. We don't if we could try to do better, but the only way to get more of one thing is by giving up some of the others. So you can see, if we're at point C and we want to get more smartphones, well, yeah, we can get more smartphones by going to D, but we also have to get less food, right? So we're not wasting any resources. We're using all the technology and all the resources we have. We're doing as best as we can at all these points along. The only way to get more of one thing is to give up something of the other. So you're efficient in the terms of you're not wasting anything. You can see that E is an inefficient point, productively inefficient point, because in the case of E, we could get more of both. Okay, and we could get more of both because E is just not using all the resources. Either not using, it's not using all the resources that we have. So anyways, now how does the other type of efficiency we have, allocative efficiency, fit into this diagram? So in this case, the diagram allocative efficiency, okay, would be about which point to choose. So this is about choosing the combo of the combination of goods, okay, choosing the combo that will make us as a society as well as possible. And to use some fancy language here, we can say this, that we can say maximizes social welfare, which means, oops, let's take that out later on, that we're choosing the combo that will make us as well off as possible. Okay, so anyways, we have our two kinds of efficiency. Now, at this point, we don't have any guidance about how to do the second kind of efficiency in this diagram. And we're not going to do that at this point, but I just wanted to point out what that would mean. It's about choosing which one of those, and it's really about which one society likes of those things. Okay, so let's move on. And we're still going to stick with the PPF, but we're going to do a little different problem. Before I do this, I want to mention this word opportunity cost. Okay, so opportunity cost, and opportunity cost is the highest valued activity that one must give up to engage in. Actually, let me change this word activity, highest value alternative, okay, because it's an alternative to engage in an activity, okay? So anyways, so we're gonna see this opportunity cost in the context of our PPF. So let's go ahead and do that. Okay, I'm gonna do a slightly different example. Let's go food, and we'll do clothing here. I'm going to use different numbers than before because our numbers before were going to be a little bit of a pain when we started doing calculations. Okay, so let's say we can produce, with all our resources in our society, we can either produce, if we do all food, we can do 500 units of food. We'll do all clothing, we can do 100 units of clothing. Then that would also mean that if we want to do something in between, I won't pick the middle this time. We could pick we could do 300 units of food, and I believe that will give us 40 units of clothing. We can just label these A, B, and C, and where A, B, and C are all productively efficient. So now we want to say, well, how do we find the opportunity cost in this graph? So really the opportunity cost is, well, if I wanted to switch from one of these activities to another, what would I give up? Okay, so that's what opportunity cost is in this setting. So, for example, if I want to go from A to B, right, you want to go from all food, no clothes, so you got all the food in the world but you're naked, and you want to have some clothes, so we're going to go to B. Well, then in that case, what are we going to have to give up? Well, the answer is obviously we're going to give up food, but opportunity cost is really how much are we going to give up? Okay, so we can divide our thing into two parts. We'll go from A to B. So what are we going to give up, and what are we going to get? So we're going to give up food, and we're going to have only 300 left, and before we had 500, and so we can that one's we're going to give up 200 units. Okay, since I'm saying give up, I'm going to kind of ignore that negative sign, and then what are we going to get is the other part. So what are we going to get? And so we're going to get clothing, and the question is, well, how much? Well, we get 40 now, and when we were at A, we had 0, so we're going to get 40, and so then now we can calculate our opportunity cost. So our opportunity cost of going from A to B, it's going to be what you give up, because that's your cost, and compared to what you get. Okay, so we're going to take away the negative sign here. We're just going to turn it into it's just going to be absolute value. We'll just so we give up 200 and we get 40. So that's our opportunity cost. Okay, so we got to finish this problem. So we can get rid of those zeros, and then 20 divided by 4 is going to give us 5. Okay, and so that's our opportunity cost. But the question is 5 what? Okay, so the opportunity cost here of clothing, because in this case we got clothing, is that one unit of clothing is going to cost us 5 food. We can call it units of food. I'm just going to say 5 food. Okay, so that every time we want one more unit of when we get one more unit of clothing, we have 5 food. Now, if we go the other way, it's also true. So we can go the other way, and it's also going to be true. So for example, if we go B back to A, what's going to happen? Okay, let's suppose we're going from B back to A. What's going to happen? So yeah, right. It's going to be the same idea, but reversed. Okay, I'm not sure if you can see that. If you want to really use your time well, you might want to pause the video, work the problems out, and then see if you got it right. So in this case, we go from B back to A. What we give up? Well, we give up clothing in this case, right? So we're now going to have 0 again, and we're starting from 40. So we give up 40. The give ups always should be a negative if we do this calculation right, but we just that doesn't really matter. And then what do we get? Okay, well, we get food. And how much food do we get? Well, we end up with 500, and we started with 300. Oops, take that out. Started with 300, so we get 200. And then remember, for opportunity cost, we put what we get compared to what we give, right? So we give up, and versus what we get. So that's going to be 40 compared to 200. A little bit again, that'll be that. And a 4 goes into top and bottom, so we can divide top and bottom by 4, and we get 1/5. So, and then just to finish it off, we can go ahead and write this as 1, because we're getting food. So 1 food is costing us 1/5 of a set of clothing, because that's what we're getting at, right? So it's costing us that. So notice something. One thing you should notice right off the bat is that these are reciprocals of each other. Okay, so if this one is a 5, then we reverse it, it's going to be 1/5. In fact, we didn't have to go through all this calculation. We could have just taken the one above, and that was 1 clothing equals 5 food, and we could have divided both sides by 5, right? I'll do that right now. So you can divide both sides by 5, and then you would get 1 food equals 1/5 of a clothing, right? So that's a possibility. I'll pick up a little bit more about this in our next video.